Hi y'all, in this video I'd like to continue working on the unit circle and try and just build up your comfort level with what cosine's doing, what sine's doing, things like that. Okay, so this is the ant problem. We want to picture an ant crawling around the outside of the unit circle, so it can't come into the middle, it's stuck on just the circular ring. And we want to figure out how you'd find its coordinates, its x and y coordinates to be really specific, if you know the following information about what it actually did. So this first one is the ant starts at 1, 0 and crawls 3 units counterclockwise. I think this is repetitive. This is the same numbers as one we saw before, but we'll still use it. Okay, so again, you don't want to be attached to radians having to be in terms of pi. That's absolutely not the deal. It's just very nice if it's a multiple or fraction of pi, because we know exactly where we are if we've gone pi or 2 pi or 3 pi or so on radians. Okay, so if we go 3 units counterclockwise, we are going to land just shy. So this is what 3 units around the outside of the unit circle looks like. I know this because pi is 3.14 and I'm just shy of that. If I want to find the ant's coordinates, I get its x coordinate by telling cosine how far the ant is from 1, 0. And I get the y coordinate by telling sine how far the ant's gone from 1, 0. So here's my starting point, 1, 0. And I know exactly how far I've gone, 3 units. So this is just going to be a cosine 3 sine 3. Okay, so this is the idea, but we want to do some that get a little bit trickier. So, okay, another unit circle. Once again, we're going to start at 1, 0. That makes life easier. We don't get to do that in all of these. And we have the ant crawling 4 units clockwise. Okay, so we're going to head down and not up this time. So heading down, I know that if I go exactly halfway around, that's 3.14 units. And if I go, so each quadrant is 1.57. Pi over 2 is about 1.57. So if I go 3.14 and then another 1.57, let's see if I can add in my head, 4.71, I think is what I'm getting. So this is 3.14, this is 4.7-ish. We want to go 4 units. So I'll say somewhere right around here in quadrant 2 for sure. And you don't have to be exactly spot on with this, but just general idea where the location is good. So this is what the ant's path looks like. And once again, we just want to figure out what exactly we have to tell sine and cosine in order for it to give us back the correct x and y coordinate. So in this one, there's nothing too crazy again. We're starting in the right spot, so that's good. Sine and cosine always assume that what you give them tells you, or tells them how far you've gone from 1, 0. So we know we've gone 4 units from 1, 0, but we need to tell them that we want the opposite direction. And to do that, you'll just use a -4. So if you want to go the opposite direction, that's what the negative sign does for you. Okay. Part C. Part C starts to get a little bit trickier because we're not starting at 1, 0 anymore. We're starting at 0, 1. So we have the ant starting at the top of the circle. And then the ant goes 2 units counterclockwise. Okay, so counterclockwise is going to be our usual direction. And if we go 2 units, remember again, 1 quadrant is pi over 2, which is about 1.57. So we've gone a little further than that. So this is what the ant's path looks like. So as usual, we're looking for what to tell cosine and sine if we want them to give us back the x and y coordinate of this final point down here. This is the point we're really interested in. So here's the trouble. We can't just tell cosine that we went 2 units, because cosine will then assume that we started at 1, 0 and went 2 units and ended up somewhere up here. So that is not good enough. We have to be a little more clear. So there's always more than one way to do this. The one that jumps out at me is if I want to tell cosine how far I am from one, let me see if I can say it right. Yeah, 1, 0. As soon as I throw 0, 1 in, I want to say it backwards. I just need to say, okay, well, I know that from here to here is 2 units. So this is 2. And I know that from 1, 0 to where I started is pi over 2. So I've gone pi over 2 plus 2 units, or I am pi over 2 plus 2 units from the starting points that sine and cosine want. So we need to tell cosine that we're pi over 2 plus 2 from the starting position, and we need to tell sine that we're pi over 2 plus 2 from the starting position. So again, what's a little confusing to people, I think, is that the ant starting position is not 1, 0, but sine and cosine always assume that you're starting from 1, 0. Okay. Hopefully these ones are sinking in. Let's try another. I've got 2 more. So now we want the ant to start at negative 1, 0. So over here. And go 6 units clockwise. Okay, so clockwise is going to be backwards. So if we start here and we want to go 6 units, we know that halfway around is 3.14 units. And all the way around, approximately, right? Approximately 3.14. All the way around is approximately 6.28 units. So we have gone almost all the way around. Not quite, but almost. So this is what the ant's path looks like. Okay, so as usual, we want to get cosine and sine. We want to outsmart them. Even though we didn't start in the right spot, we want to get cosine and sine to give us our x and y coordinates. So again, there's multiple ways to get there. Here's what I'm seeing. If I want my starting place to be here, to get to where the ant actually started, I have to go pi units. So I could go pi units to get over to where the ant really started. And then I would need to go back 6 units. So that's a -6 to end up where I really wanted to end up. So I'm going to write that down, and then I'll talk about some other possibilities, at least one other. So you could go pi -6. And that would land us in the right spot. Another way you could do this is go negative pi and then -6 if you want it to all be negative, so you don't have to switch directions. That would be fine. You could go 3 pi -6. So anything that gets you over to this point minus a 6 will be great. One other thing I want to clarify on this one, I kind of showed this as a path for the ant, right? So we went pi, and then we went -6, but the actual distance pi -6 is just, or the actual arc length pi -6 is just this. So it's starting from 1, 0. These two wiped each other out, right? We went pi and then we went back pi. So that just wiped itself out completely. So really all we have to do to go pi -6 is to head down this way. Another way to think about this is 3.14 minus 6. So it's in the ballpark of -3, not exactly, but in the ballpark of -3. So here's what we're seeing is that a pi -6 does not really mean go here and then all the way back. It means from here, go the distance pi -6, which is roughly -3. Okay, one more of these. Let's say the ant starts at 0, -1. And crawls 5 units counterclockwise. Okay, so this is going to be our usual direction. 5 units. Let me think about this. So we know this is 3.14, and earlier we did the arithmetic and figured out that 3/4 of the way around was about 4.7. So it's just a little further than that. So we start at the bottom, we go a little bit more than 3/4 of the way around, and we're going to land somewhere in quadrant 3. So this was the ant's path. And we want to figure out what to tell sine and cosine in order to get the x and y coordinates of this final point. So cosine, sine. Okay, so we need to figure out how far our point is from 1, 0. So again, you have some choices. You could start here and go this way to get to your point. Or you could start in the same spot and go the opposite way to get to your point. Either way is going to be fine, and there's of course more options. You could start and go all the way around and then continue till you get back to the point. So round and round and round and round as many times as you want, and then at some point you're going to have to do this last little leg. So if I want to figure out what these are, if I go back to the ant's path, I know that this, see if I remember what it was 5 units. So this is 5 units. So what can I see? I could see that I could do 5 minus a pi over 2. So if you're thinking about that as a path, I would say to get down here, I have to go negative pi over 2. And then from there, I had to go 5 units around. But that really is the same as 5 minus pi over 2. If I want to go this way, let me think about that. What is that one? That is, I think, a pi over 2 minus 5. So I don't know. I think that one's a little more confusing to me. But if we think about paths, let's see what you could do. You could go 3 pi over 2 plus 5. That would be a good one. You could go, we already did negative pi over 2 plus 5. I think those are the two easiest. So I'm going to stick with my negative pi over 2 plus 5 or 5 minus pi over 2, whichever way you like to have that one. Okay, so again, it's completely okay to kind of think about this as I go negative pi over 2 to get here and then 5 to get around to where I actually want to be. But to be really clear, so you're not picturing these things incorrectly, the actual distance traveled there is not pi over 2 and then 5. What this tells cosine to do is start at 1, 0 and go 5 minus pi over 2, which is the purple distance. So we've really just gone the purple distance. Okay, that's it for this one. Thanks for watching.